Hello and welcome to this Spatial Spotlight. I am Tomas Ehrenfeld. I am a solutions engineer in CARTO. And today we will be going through an exercise to see how we can analyze over 140 million data points representing taxi trips in New York City using CARTO, BigQuery, and spatial indexes. So without further ado, let's just jump right ahead to the exercise and we will discuss the data inputs and the technologies that we will use to be able to make analytics on this big data. So I will just go ahead and share my screen. Uh, so you should be able to see my screen. And what we're seeing now is BigQuery. So the reason why we're doing this in BigQuery is because BigQuery has done an exercise where they uploaded these 140 million taxi trips, which is open data from the New York City, and they made this data available in an open data project. So we will use this data, which we can see in here. In the details, is 146 million rows, weighing a total of 18 gigabytes. And we can see in the schema that we have both the pickup and drop-off daytime and the pickup and drop-off both latitude and longitude. So if we take a preview of this data, we can see what it looks like. So we have the pickup and drop-off locations, and then a lot of other attributes that we won't be using, such as the amount or distance and other attributes. For now, we will just use the date and the location of the start of the trip and the end of the trip. So in order to analyze this huge amount of data, we really need to use some sort of grid system so we can visualize it. So in order to do that, we will use a global discrete grid system, and we will discuss that in a minute. So the first thing that I'm going to do is I'm going to run a query within the query that is partitioning by date, because this is a huge amount of data, and I will be querying different parts of this data set. And I will also cluster by this pickup and drop off, but transformed into H3. H3 is this spatial index, this global discrete grid system that was created by Uber. And we will discuss that in a minute. So because we have our pickup daytime, we will just use our extract function to get the day of the week, and we will label this as the day names. So we will call this day of week, and we will have Monday to Sunday, and we'll store that in a column. Then we will also use the extract function to get the hour, and we will classify this in morning, afternoon, evening, or night, and we will call this part of day as well. And then we will use this CARTO function. This is a function developed by CARTO, a user-defined function that is open source. So CARTO created it and made it available for anyone using BigQuery or other databases to be able to leverage this H3 transformer. So what this is doing is taking, in this case, the pickup longitude, and latitude, and a given resolution. So what does this mean? This means that we will have this global discrete grid system that will have some sort of hierarchy. We will have different resolutions. So in this case, it's H3. It's a hexagon type of representation that will have parent and children hexagons that will fall within the hexagon, or each hexagon will be part of a bigger hexagon. And what this does is this encodes the location of the latitude and longitude into a 64-bit integer that allows for really high performance when computing um, geospatial computations, such as what are the children, what are the parents, what are the neighbors, which are the distances, and these sort of computations. We will see that in a minute. So we will grab our pickup and drop off coordinates. We will select a resolution of 13, which is a pretty small hexagon, and we will call this H3 pickup and H3 drop off. We will see how that looks like in a minute. Then we're also doing some data validation so that our coordinates fall where they should, and that is it. So when we run this, and this only takes a couple of minutes, I think it takes less than 3 minutes. You can check on your own once we make this code available. We will get something like this. So if I just run this and I get the first 50 rows of this table that we just created, that is partitioned again the date and the H3 pickup and drop off, we have our date, we have our day of week, we have our part of day, and then we have our H3 pickup and drop off. So we can see this string representation is a 64-bit encoder that is representing a hexagon in space, and we will be able to visualize this in the card. So how will we use it? So to start, we can already see, if we go to this table, we can already see the details of this. We were able to reduce the table size by half, and we have again the same number of rows, of course, because we kept all of the trees. But in order to visualize this, what we will do is we will create a computation, a normalized difference of the pickups and the drop-offs. So we want to understand the relationships between the incoming and the departing trips for any single point in space. So what we will do first in this second query, which we will visualize in a minute within CARTO, is we will first create a CTE called data, where we will filter for some filters of interest. So in this case, I'm filtering, for example, for January, so the whole complete month of January in 2015. And then I'm interested in day of week being a Sunday and the part of day being a morning. So this is the data that I'm concerned about for this particular query. And then I am creating two other CTEs, a pickups and a drop-offs. And what I'm doing here is I'm grabbing my H3 pickup, I'm renaming it as H3. And then I'm counting the number of pickups happening at each H3 cell, and I'm grouping by the H3 pickup. So again, I'm grouping by H3 pickup and then counting the number of pickups that are happening. And then in drop-offs, I'm doing the same thing, but I'm doing that with drop-offs. So I'm grouping by drop-off, and I'm calling this H3, and then I'm counting the number of drop-offs. And then what I can do is I can join my pickups and my drop-offs based on the H3, so using H3, and I have my H3 cell. So let me just run this. And you can see that this computes really, really quickly. So this was just analysis on 146 million rows, and it computed, in just a fraction of a second. So what I have is my encoder for location, the number of pickups that happen, the number of drop-offs, and then this field, which is the normalized difference. Now, the normalized difference is a really interesting way to do an analysis on the relationship between these two variables, the pickups and the drop-offs, because it will always go from -1 to 1. And the way in which we're calculating this is we have our P stands for pickups and D stands for drop-offs. So we have our pickups minus our drop-offs divided by our pickups plus our drop-offs. And what this means is that if we only have pickups, then we will have 1, or whatever this number is, minus 0, so just pickups, divided by pickups plus 0, so pickups divided by pickups, that equals 1. And if we only have drop-offs, then we will have 0 minus whatever number of drop-offs we have, divided by 0 plus our whatever number of drop-offs we have. And again, minus drop-offs divided by drop-offs, which is -1. So this will always be from -1 to 1, as you can see in this variable. So in this case, for example, this is minus 0.5. We have way more drop-offs than pickups, for example. And in this case, so this is minus 0.5. In this case, we have 13 pickups and 3 drop-offs. So this is 0.6. So you can see how this oscillates, and it allows us to understand in a really comprehensive way the relationship between pickups and drop-offs, so incoming and departing trips. So how do we do to actually visualize this on CARTO? Or how do we do to have some sort of visualization to allow us to understand what is happening in space? So for this, what I will do is I will jump to an empty builder map, which we're seeing right now, and I will create a new source from a SQL query. So in this case, I'm using a BigQuery connection that allows CARTO to query BigQuery directly. And if I just paste this code in here, I'm doing the same analysis that we did before, just dropping the limit 50 that we had at the bottom. And CARTO already understands that this is an H3 layer. So just by grabbing this 64-bit encoder, that string representation, CARTO will be able to plot this and to represent the geospatial meaning of that H3 encoder. So we can see already that we have our hexagons here. We can visualize them. And if I zoom out, you see that the resolution is actually changing as I zoom out. This is because, as we were saying before, this is a global discrete grid system that has a hierarchy that allows us to really smartly compute which are the parents or the children of each single H3. So we can represent this for any zoom level at a resolution in which it makes sense. But we can't really see anything from here. So what we will do is we will access this layer, we will click on it, and we will show how we want to represent these H3 cells. And basically what we want to do is we want to compute the average. And again, this is an aggregation method because we have maybe for each of these H3 hexagons that we're showing right now, we might have hundreds of little H3 hexagons within them. So we're computing the average normalized difference of these variables. So whenever I do this, I automatically get a color scale and a color palette. So let's select a diverging color palette of 5 steps, going from red to blue. But then I want to customize it because I want the middle step to be actually some sort of gray, something like that. Then I can also customize the the classification. So in this case, I want to have from -1 to -0.5 and -0.5 to -0.25, then to 0.25 to 0.5 and to 1. And then if I apply this, I can, you will now see if I increase this resolution. So again, if I zoom in, I get more resolution, right? This is being computed. We'll see the results in a minute. So I get a higher resolution. But if I want to have an even higher resolution for lower zoom levels, such as this, I can use this parameter of resolution, which is basically the relationship between the zoom level of the map and the resolution at which I am computing these results. And basically what we're seeing here is wherever we have really values close to 1, we have a lot of drop-offs. So we're concentrating people. That's why I'm representing it in red. So in these cases, we're seeing a lot of people arriving to these locations and not that many people departing from them. And in the color, in the places that are close to bluish color, and we're seeing a lot of people departing and not that many people arriving to those locations. So let's take this a step further, and let's see what we can do to actually make this map more interactive. Now, in this case, we have the exact same query, but as we were saying before, in this query, we are establishing our set of filters, static filters. And what we can do in CARTO is we can create SQL parameters that allows us to filter these queries dynamically. So we can create date, numeric, and text filters, and we can include them in our queries as such. So in this case, I replaced our query. You can see this is exactly the same query, but instead of giving a fixed value for the filters, I am including this weird syntax of the brackets and then a variable name. And this is basically all of these filters that we're seeing here. So a calendar and then some category filters. And we can just use them in here in this query where I'm filtering the data for a certain day of week, a certain part of day, and then a certain date from and date to. And you can see how you can customize this. If I edit this parameter, you can customize the values that are allowed on these filters. So in this case, we're seeing, for example, for just on April 2015, what was the incoming and departing traffic on a weekend, specifically on the morning. And what we can do is we can maybe say, okay, but I'm interested in the first 2 weeks. and then I can filter it just like so. And you can see how this just changed the data that was on the map. So if we, again, if I go here, I will get the data for the whole of April. And if I go to widgets, I have already created a set of widgets that allow me to understand what is happening on this area on this extent. So for example, I have a pretty normal relationship between the pickups and the dropoffs, for example, being 320 and 380,000 trips, pickups and dropoffs. And I also have a histogram that allows me to understand on this side the areas that are having a lot of pickups, and we can see that clearly most of the pickups are happening on the avenues, on the main avenues of Manhattan. And if I do the opposite, I can see really clear spots where the drop-offs are happening. So clearly there's some point of interest or something that is happening on these areas that any agency such as Uber or any other will want to consider to balance the system of incoming and departing trips. And then we can also, as we were doing before, if I filter this by the dates, I can see how this is being filtered again, and I have 120 and 135,000 trips for the weekends of the first week of April. And then if I want to see what happened at night instead of morning, then I can just change that, and again, we will see this reflected on the map. And we can see that during the night, there's much more people actually departing. So if we see now the widgets, we can see there's way more trips at night, and there's a lot more pickups than drop-offs, over 150,000 more pickups than drop-offs. So a lot of people departing from Manhattan that night on the weekends, which makes sense. And we can see that happening on the map. What you're seeing on the gray areas is also really interesting because it means that these areas have a pretty balanced relationship between pickups and that is about it. So I hope this was interesting. We will make available the code that was used for this demo because the data is open sourced by the New York City government, and the function to actually be able um, to create these H3 cells is also available because CARTO open source the technology. They use certified functions to be able to run that. So um, you're completely capable of running these same queries. And if you want to test this in this same CARTO builder tool that I just used, you can also sign up for a trial, and you get a 2-week trial that you can use to test everything that I have just been doing and much more. So hopefully this was interesting, and please leave any questions on the messages, and we will be replying to them. Thank you very much, and until the next time.